Heaviside function t1, okay, t greater than 0, sorry, less than t1, okay, f of t greater than t1 greater than equals to maybe no problem, okay, less than t2, and f of 3 t. So break of functions, okay, if this one is the situation, what is the t3? So this the function is defined f of 1, f2, f3. What will be the Heaviside function, or how can you write the function f of t in terms of Heaviside function? So let us consider first one only is there, okay, there is no second one, so it is defined from 0 to t, okay, so the function is defined 0, t1, t2 and t3, this one, okay. Just tell me what will be the function if only f1 is there. What will be the Heaviside function? That is, we can write f of t in terms of Heaviside function. So f1t rest what will be the h function, Heaviside function? H of t, correct? Is since a is 0 here. Now let us first if you only this one is there, okay, now first one is there, and discussing like that. If this one is there, so now the bounded one is the function, Heaviside function is representing like that. If both are there, first two, okay, can you add something? What will be the answer? f1t into h of t. So that one is the first one. Now second one, from t1 to t2, there is no f of 1 here. So f of 1 should not be there, but f of t should be there. Okay. So and since t1 and t2 both are there, not 0, so I can write like that. Okay. Plus only Heaviside function I will write. Rest but you have to answer h. Okay. T minus t1. But should I write ft2 or something else? So ft2 or something else. I'm waiting for your answer. Is it correct? No. So the answer is f of 2 minus it is minus f1t, then this one. Now it is easy for the all three functions. So that means f of t. So first case f1t, if it is f1t only there, that first step. If f1, sorry, ft2 and f1, sorry, f1t and f2, f2t both are there. So after that one. Now f of, sorry, f3 also there. So then what will be the answer? The answer is finally total form. Okay. Heaviside function of t minus t2. Here it is f3t minus f of t2. Okay. This is the form of the Heaviside function for this type of function. That means what type of function? When the function f of t defined in different interval. Okay, that means break is there. Okay, so what is the meaning of that one? So if you consider t1, t2, t3, say that if t1 to t2 function is this form, just consider it like that. Then t1 to t2 to t3 like that. Okay, again maybe like that. Okay, or you can say the break like that. Okay, so if this type of function, that means here it is f1, this is f2, and this is f3. Maybe at t1, t2, t3, the finite number of discontinuity. Okay, this is the form of Heaviside function. That means you can write any function f of t like this form. Okay, now this type of function. Okay, if it is not there is no discontinuity, directly you can write like earlier page. Okay, if you go to the previous page, this one. But if you have break like that, then you can write in that form. Okay. Another form is that, okay, that is called again top hat function, that is this function. Okay. So now, okay, let us see. I will give you one more function. Okay. So now you have to write Okay, the Heaviside function. So you know two type. You know this two type of function, h of t and h of t minus a. Correct. So now I will give you one function f of t. You have to write in terms of Heaviside function. F of t is 1 if t greater than equals to a, less than b, 0 if, okay, that means otherwise. Then you answer what will be the answer. Sorry, what will be the form of the Heaviside function for this function? The function is defined. Okay, this is the function. Write down the function in terms of Heaviside function or unit step function. A be any value particular. No one is there, I think so. Otherwise, it is easy to answer. It is very simple. You can easily answer it.
Can you explain that part again? Can you explain that part again, sir? That Heaviside function?
Okay. This one is clear?
Yeah, this is clear, sir.
This is the definition of a Heaviside function. Okay, and two form t minus a. This is t minus a. This is t minus a. Okay, now Heaviside function of t minus a. Okay. If this one is clear, next one, is it not clear? It's not
Here
clear.
it is a bit confusing, sir.
Confusion. Okay, that's why step by step I have actually considered f1t. If only f1t is there, what is the answer? Okay, you know, I am not going to fuzzy logic. Okay, na, just simple one. Okay, you know the washing machine, correct?
Yes, sir.
What it is actually, just for you, what is the first function of the washing machine? Okay, after if you start it, okay, after putting everything, okay, detergent and clothes, so then it will give first water will come, correct? Water
Yes,
only.
sir.
So that one from 0 to T1 only water, and it may be moving sometimes. Okay. So this one, say function T1 only water. Okay. Then T2, okay, the next part. That time T1 will means T1 automatically switched off. Correct. Then after that, okay, then they will give some actually some time for another function. Okay, that means for dryer, okay, it will run first, okay, now move first, and then all the water will remove from the that washing machine. So that is T3. So that time T1 is off. T1 is means water in sorry that water line is off. Okay, T2 is another function. Okay, doing some cleaning. Correct. So this is, that means during 0 to T1, T1 only working, sorry, F1 only working, F2 and F3 both are off. Okay. So you see the function right hand side, this graph. Okay. From 0 to T1, only F1 is working, other function are switched off. Okay. From T1 to T2, only this function is working. Okay. Other two functions, that means F2 switched on. Okay. And at what time? T equals to T1. And simultaneously at T equals to T1, F1 should be switched off. Okay now. So here F1 is switched off, F2 is switched on. So and from T1 to T2, only F2 is there. Okay, but if you consider the Heaviside function from this one, that means from 0 to T1. But 0 to T1, okay, so from 0 to T1, from 0 to T1, correct. Let me just see, from 0 to T1, for this case, okay, only when up to T1 it will work, correct. So up to T1, this one will work, okay. And next case, f2 should not be next to only f2 should be there, not f1. That's why minus f1. Third case, okay, the third case is actually only f3 should be there. Okay, there is no chance of f1, so only minus f2 from t2 greater than t2 less than t2. Since already others are already discarded, so only for this case you have to think. That means that is f of t there. Okay, f of t, sorry, f3 minus f2. So oh sorry, I have written wrong, f2. Okay, that will be f2.
Sir,
Yeah.
the first term it will exist for greater than T1 also, no, sir? That F1 of T into H
Yeah,
of
greater than of t1. That's why here it is minus. Just check. That's why f1. It is not ft1. It is f1. Similar case, when it is t greater than t2, also f2 will work. Correct or not? But that's why I have written it is wrongly f of not f of t2. It is ft2. Correct? Like earlier one. Okay. So f3 minus f2. Correct? During greater than t2. So that's why I have given right hand side also f1, f2, f3. Okay, this is the region. Okay, so ft3, this one, this one. So these are the function, three different function. Okay, this one another function. This is the gap, another function. Maybe some gap again. This is the gap. Okay, but that time no one has asked any questions. Okay, now this one. Okay, f of t equals to 1 if t greater than equals to a, less than b, and 0 otherwise. That means the function is defined from a to b. So now you tell me what will be the, and what is the value of that one? 1. So let us see. I'll increase a little bit. Okay, you can easily answer it, I know, but just for, okay. So now this is, now say this is 1, this is 1. So what is that one? This is a to b, correct? Now you tell me, can you, so two functions are there, h of t, h of t minus a. Both are unit step function, two different form. So from 0 to a, what is the answer? From 0 to a, what is the answer?
0, sir.
0. Okay. So now, and from a to b, it is 1. Correct. So
Yes.
if I now I am writing, okay, h of t minus a. What is the answer? What is the meaning? It is 1 for all values of t greater than a. Correct.
Yes, sir.
That means it will exceed b also, starting from a to infinity. Correct.
Yes, sir.
But is it the interval for your problem?
No, sir.
Where you have to stop?
At B.
Before b. Correct now. At that means you can say at b. So how much you have written extra? I am giving
From B to infinity, sir.
You just see, I am giving a star, correct? And so on. Continue. So can you answer what is this part and dot dot dot? Okay, now what is this part? Heaviside form or unit step form. That means unit step form. What is that one? The bracket one.
H of
T
t minus
greater than b. So what is the meaning of that function? What is the notation of that function? H of
T minus B.
t minus b. That one we have written extra or what?
Extra, sir.
Extra. But so from this one, what we have to do then?
Subtract.
Subtract. Finished. Clear? So f of t is nothing but h of t minus a minus h of t minus b. So f of t, if you are write f of t like that, or else you can write like that also. What I either you can denote this one or you can Is it clear or not? If anybody having any doubt, I will discuss it again. But graphically also I am showing. So it's just see from A, okay, and this one B. If you write this one, okay, so this part also should be included. Means it is there. It is including this part. But this part is actually only this part, not this part. Okay. So that means this one is extra if you consider this problem. Okay. So that's why it is subtract h of t minus a, h of t minus b. I will change this one. Okay, I will change this one. Okay, g of t. Now you answer. Okay, you should answer now what is the functional, sorry, unit step form of the function.
G of t into Hebesaid of t minus a minus Hebesaid of t minus b.
Good. So g of t equals to, so this function. Anybody having any this one? No. Clear? So
Sir,
now,
sir,
huh?
what is the advantage of writing that Hebesaid function? Sir?
Okay, I will go. Okay, I will consider one problem, then I will discuss. Okay.
Okay, sir.
So Heaviside function. Now we'll consider the Laplace transform. Okay, why we are writing actually Laplace transform? Sorry, the Heaviside function. Okay, say okay. Well, I will discuss that one also. First, we will consider one Laplace transform of a Heaviside. Sorry, of a function. Okay, and initially it will be not written in the Heaviside function. Okay, what is first? Okay, shifting property. What is the first shifting property?
That multiplication with e power at.
Okay, good. Till now we have not discussed second shifting property. We'll go there. Okay, now after sometimes. Okay, so you have to wait. So now one example. Okay, f of t equals to. Earlier we have not done all this, only continuous function. There is no discontinuity. Okay, now and directly we have written okay the Laplace transform of that given function. If it is discontinuous, we have written two different function also, no problem. Okay, now till now only we have studied t, okay, cos of 2t, cos of t, sine of t, exponential t, okay, or algebraic function and sum. Okay, we have not considered this type of function earlier, correct? So only standard functions. What are the standard functions? Okay, roll number 23. Are you there? Okay, 24. Yes. 28. 32.
Yes, sir.
Okay, 32. Your roll number, correct. What is the Laplace transform of t? Immediately you have to answer.
Yeah. 1 by s square.
1 by s square. Good. Okay. Roll number 42. Roll number 42. Okay. 46. 46.
Yes, sir.
Okay. But what is the Laplace transform of sin t?
S by s square plus 1.
Okay. And then cos of t?
Sir, sorry, sir. I told you.
Now you got, I got the answer. Okay, now no need to answer anymore. Okay, since you are sorry, that means you are now going to answer correct only. Okay, so earlier we have studied like that cos of 2t e to the power minus t e to the power t and so on. Okay, we have not considered any function like f of t equals to this one, this one, this one, correct? So now we are going to discuss such type of function. You just see now. Okay, So now f of t equals to 2t square, okay, t plus 4, okay, and 9. So what will be the Laplace transform when t greater than equals to 0, less than 3, t greater than equals to 3, less than 5? Just few minutes back actually, okay, if I go back, you can find all this one, this function, f1, f2, f3, f1, f2, f3. Okay, so these three function, three different nature also. Last one is constant. That means, okay, a straight line. Okay, but t plus 4 it is linear increasing, and 2t square it is almost rapidly increasing. Okay, now. So now you have to find the Laplace transform. Find the Laplace transform of f of t. So what will be the answer? So that one actually we are going to solve now. Okay. Solution. Okay. So f of t now, okay, f of t we can write in terms of, okay, Heaviside or unit step function. I'm waiting for your first response. What will be the answer?
What, sir?
What is the in terms of Heaviside function? This function in terms of Heaviside, sorry, unit step function. Okay, using the concept of unit step function, we get h of t equals to
2t square into h of t, sir.
okay 2t square into h of t. Okay, 2t square into h of t. Correct. Next,
T plus 4 into h of t
t
minus
plus 4 minus h of
h of t minus 3 minus h of t minus 5.
just see what I have written. T plus 4 minus 2 square. So f2 minus f1, f2, f3. Correct. So t f2 minus f1, f2 minus f1 into h of t minus 3 plus, what is the answer next? 9 minus
9 minus t plus 4.
t plus 4. Okay, this one. So
H
it
of t
is
minus 5.
h of t minus 5. So this is the Heaviside function. Okay.
Sir,
Unit
instead
step.
of doing like that, like instead of considering f2 minus f1, if we consider only f2, then do we get that big range, sir?
Yeah,
Like
no,
we
no,
did
the
before?
problem is actually that means from 0 to up to that one you are considering, up to 5, this function.
Yes, sir,
So
if we
if you-
consider from only 3 to 5, sir.
No, how can you write that Heaviside form? Another form is there.
Okay, sir.
Are you understood what I am telling?
Yes,
So
sir.
yeah, so only from 3 to 5 this one is there, but not from 0 to 5, 0 to 5 or 0 to 3. Understood? If it is 0 to 5, then easily you can write that one, no problem. But it is not like that. Okay. So only this one. Okay. So now we can write. I'm not using. Okay. Laplace transform till now. Okay. Now so plus 4 plus t minus 2t square Heaviside function of t minus 3 or unit step function of t minus 3 plus, okay, plus 9 plus 4 sorry, 9 minus 4 5 minus t h of t minus 5. Till now I have not given what is the Laplace transform of unit step function. So if any function is given like that, okay, then you, okay, you can say that, sir, will take Laplace transform of separately, okay, and then we will add it since it is 0 to 5. But it is not like that. Why? The range is discrete range from 0 to 3, 3 to 5, and greater than 5. You can't add. So to overcome that difficulties, only we have to consider the Heaviside function. Okay. So here it is, there is no range is given. the function itself will give you the range. Clear? That means at a time you can consider the Laplace transform of this type of function. I will hold here, okay now, and I will go to the formula how to find unit step functions Laplace transform. Clear? So this is the step 1 to find the Laplace transform. Yeah.
Why can't we just add them, sir? Like taking Laplace transform and adding each.
Okay, I will answer it. Okay now. Say the Laplace transform, this one you are taking from the range of what?
0 to 3.
And this one, this function from 3 to 5.
Yes, sir.
And this function from t to greater than 5. If you add all these three functions, then can you write the so what is the range for t then? That one 0 to 5, correct? Sorry, greater than 5 or 0 to 5 or 0 to greater than 0. What is the range of that one then? If you say greater than 0, answer is wrong. Why? This function only define up to 3. This function only define up to 5. If you add all, and then you can't say that it is defined for all values of 0. Understood? But here, what is the called advantage? This function itself defining the range of the function 0 to, that means t minus 3. What is the meaning? T greater than, correct? T greater than equals to 3, or rather that one. So here this is the advantage of this Heaviside function. Function itself giving the range. No need to write separately the range of that one. Okay. So
Sir, one more doubt, sir.
yeah.
Sir, why can't we do it using definition, sir? Like, for example, if a function is like that, we'll use that formula integral 0 to infinity e power minus st into f of t. And
No, I understood. Now I understood your question. Why not? Okay, using this definition, we can find this one, this one, this one. Correct?
Yes, sir.
Then what will be the answer for that? All these three. And how can you write the? Huh?
Sum of all the integrals of the different functions.
That's why I'm telling you. One fellow already told sum of all this integration. But this integration, that means what will be the range of that one then, s or t? If you write s is s, the real part is greater than 5. What is the meaning? Okay, this part you are omitting. And if you are writing a real part of s is greater than 0, that means actually this function is defined for all values of, means from 0 to infinity. Not like that. This range is actually restricting you. You can't say like that. If this function is defined for all values of t, that means then no problem. What you are telling. Actually, if we go back for any function cos of t, so that means I'm telling you here t plus cos of t. Correct? What is the Laplace transform? Laplace transform of this one and Laplace transform of this one. Correct? This, for this function, Laplace transform of t plus cos of t, cos of t, this function is defined for some particular values of t, say 0 or 5 or something. Then no problem. Total function is defined in this domain. But here it is, all the functions are not defined for all the domain. It is different domain. 0 to 3 or different range. Correct? So you can't consider. So that's why Heaviside function you have to consider, since the function itself giving you the range here. So you know what is the meaning of this one, what is the range of t. So now to find the Laplace transform of f of t, this is the first step. That means you have to write the function f of t in terms of unit step function. Till now we have not discussed what is the Laplace transform of unit step function. I repeat, what is the Laplace transform of unit step function? Correct? So now I will go there and again come back to this problem. Okay. So next one is, okay. So definition, that means you can say definition of Laplace transform of Heaviside function. Okay, or else we can derive the Laplace transform. We can say this one also, Laplace transform of Heaviside function. So Find the Laplace transform of h of t minus a. Okay, for a greater than equals to 0. Okay, what will be the Laplace transform? So from the definition of Laplace transform. Okay, what is the Laplace? I will not write. If you not prompt me, okay, I will write. Somebody should tell me what is the answer. Right? 0 to infinity e to the power minus st h of t minus a dt. Am I correct or not?
Yes, sir.
Okay. Can you answer me the next one? 0 to a e to the power minus st h of okay h of sorry okay h of t minus a dt plus a to infinity e to the power minus st h of t minus a dt. We can write or not? We
Yes,
can write
sir.
any integration. Okay, intermediate points a 0 to a to infinity. Correct. So now 0 to a, what is the value? What is
Zero.
the what is yeah 0? Correct. Now I will write. So this function. Okay. For this range, what is the value? Already answered 0. Correct now. So 0 into e to the power minus st. What is the answer? So 0. Correct. So that this part we can write 0 plus sorry plus integration a to infinity. What is this value now?
1.
1. Okay. You have any doubt? You are telling like by guess or what is h of t minus a? Okay.
It's 1
1.
for everything greater than or equals to a, sir.
If t less than or greater than
Greater than or equal to a.
greater than equals to a, and 0 if t
Is
less than a.
less than
Correct
a.
now? This one. So that's why 0 to a, the t is a, t is 0. Here it is 1. So 1 into e to the power minus st dt. Clear? So now,
Yes, sir.
what is the Laplace transform of Heaviside function h of t minus a? So first part is 0. Correct now. First part
E
is
power
0.
minus s by s, sir.
Okay. So integration a to infinity e to the power minus st dt. If you consider this one, e to the power minus st integration, since it is integration minus s, so it is a to infinity. In infinity case, it is 0.
0.
Okay. And for a, it will exist. So what is the answer? No,
E power
minus
minus
plus.
a s by a.
Minus or minus plus, no?
Yes, sir. E power minus a s by s.
Okay. This one. Correct. So Heaviside function now, Laplace transform of Heaviside function is 1 by s into e to the power minus as. When the function is defined t minus a. Okay. So now I will go back. Now it is clear for you, this one. Okay. Now when a is 0, correct. So now if you can note like that, if a is 0, then what is the unit step function? H of t,
1 by
correct?
s.
1 by s. What is the Laplace transform? Whose function Laplace transform is 1 by s? What is the Laplace
T,
function?
sir.
Are you sure?
1.
So, sir, 1, 1, 1, sir.
1, 1, okay, correct. So Heaviside function when a is 0 equals to 1 by s, that is actually Laplace transform of 1. Now I will go to the previous one. Can you find the Laplace transform? I'm not telling, we will take the Laplace transform of, just 1 minute. Okay. Now we will take the Laplace transform of this function. I am going to, sorry, here, f of t. Now, first step is over. This is your second step. Correct. Instead of taking the Laplace transform of this function, we can write the Laplace, we can find the Laplace transform of f of t. Clear? Since we have written this function in terms of unit step function, okay, in terms of unit step function of the given function f of t, original function. So now, just now we have so we have completed the discussion of Heaviside function, sorry, unit step function Laplace transform. Okay, so these are known to you now. Clear? These are the known function. The Laplace transform of these functions are known to you. Okay. So now, if you know that one, what will be the answer of Laplace transform? Okay. So what will be the Laplace transform for that one? Okay. Before that, okay, I will come to you after sometimes again next. So this one we have discussed. Okay, from the definition, Laplace transform of unit step function. Okay, let us see how many. Okay, next. Roll number 45. Laplace transform of h of t minus 4. What is the answer? Roll number 45. We just see how many people are coming. Roll number 32.
Yes, sir.
What is the Laplace transform of this one? L h t minus 4.
E power of minus 4s by s.
But if you say like that, I can't actually follow. Just 1 by s into
E power of minus 4s.
4s. Okay. Roll number 55. Okay. Roll number 11.
Sir,
Okay, you are there, better. Good. Laplace transform of h of, okay, h of t. What is the answer?
1 by s.
Oh,
E power,
e power?
zero.
E
Zero.
power. Okay. Should I write e power 0?
No, sir.
Then what is the answer?
1 by s.
Good. Okay. These are. Now, okay. Just see. So you know this one. So ultimately, what we have discussed actually Laplace. Sorry. Laplace transform of h of t minus a. You know this one. Once again, I am writing. Okay, 1 by s e to the power minus as. Okay. So now we will use this concept. Okay, now just 1 minute. Okay, now I will write. This is very important one. Okay. Second, we have studied first shifting properties. Now, okay. Second, okay. Second shift theorem. So this is actually for unit step function. Actually, the application of unit step function. So what is the theorem statement? What is the statement? A statement is if Laplace transform of f of t equals to capital F of s, okay, then for, I will ask some questions. Okay, now then for a positive constant, okay, now positive constant a, okay, a Laplace transform of f of t minus a into Heaviside function of h t minus a equals to it as as into capital F of s. So this part is very important for solving one function having unit step function form. So f of t minus a h into t minus a unit step function. The answer is Laplace transform. Answer is from this theorem directly you can answer e to the power minus as into capital F of s. What is capital F of s? Now Laplace transform of f of t. Okay, capital. So this shifting, I will prove the proof of this theorem. We will discuss later on. Okay, now, but just see how to use this one. Correct. So using this one, okay. So you can write like that: Laplace transform of this one f of t equals to this type of form. Okay. So if this is the case, how can you find the Laplace transform of the given function? Okay, I will go back again to that particular problem. Okay, and then we will discuss the answer. What will be the answer? Correct. Better clear? I will discuss this one. Proof we will discuss later on. Okay, now. Proof of this one we will discuss later on, not now. Now only application. Only application. How to apply this one. Okay, so now previous page. So this one is very important. Go back here. So this one already we have discussed. Correct, this one. So I will write this part again over there. Okay, this part. Okay, and this this part I will write this part. Okay, in that new next one here. Okay, so next. So the given function Laplace transform of f of t we have to find. Okay, but this Laplace transform the function. Okay, the function. Okay, f of t already we have written in the form of unit step function, and I am rewriting here again, that is h of t. Okay, minus 2t square minus t minus 4. Okay, sorry, minus t minus 4 Heaviside function of t minus 3. Okay, minus, actually there was t 5 minus t, so now I will write t minus 5. Okay, why I am writing, you might be knowing why. Now to apply this form, t minus a. Okay, not a minus t. So this one. So now we have to find the Laplace transform of f of t. What is the time, brother? Hello.
Sir, 10:50.
Oh, up to what time our class?
10:50, sir.
10:50. Okay, okay. I will stop. Okay, just 2 minutes. Okay.
Okay.
So, or we will discuss in the next class this solution, or will can I continue that or not? You just tell me. I don't know you have class or not next. CR. Should I find this? Should I complete this problem, or next day we will continue with this one?
Sir, we'll continue next class. No, sir. We have small break only, sir, already.
Okay, okay. So should I stop here?
Yes, sir. We
Okay.
have noted down, sir. We can continue, sir.
We can continue. Okay, okay, okay. Next month.
Sir, next class.
Oh, next class. Okay, better. Okay, then. Okay, we will discuss this one, how to solve this Laplace this function. Okay, the next class, and also we will discuss how to solve the second shifting theorem. That is also called decay theorem. Okay, the next class. So you can leave.
Thank
the
you, sir.
meeting now. Thank you. Okay,
Thank you, sir.
you can leave the meeting now.
Thank you, sir.
Thank you, sir.